But I'll tell you that they're actually different. Molecules and compounds are not the same by definition, but we'll talk about that later. All right, so chemical bonds. Great, I just got a black dot on my shirt. Naturally, it hit the yellow and not the brown. All right, chemical bonds is the reason for chemistry.
And that's all you need to know.
Yep, that's it. So chemical bonds result because of the attraction between charged particles, that can be electrons or protons, that compose atoms. There are three types of bonds, ionic, covalent, and metallic. We do not consider metallic. If you go on to advanced inorganic chemistry, which you're probably not going to do unless you're a chemistry major, then you will talk about metallic bonds. We will only consider ionic and covalent. So,
Do we need to know all our polyatomic ions by Friday?
yes. And actually, tomorrow I'll give you a bonus quiz on the polyatomic ions. So that'll help you if you didn't do so well in the first test.
Or it helps to write them, like do acetate, do whole page, do carbonate, whole page.
And you do have to know their charge.
Yeah, that's about it.
As well.
Yeah.
We'll get there. All right, so let's talk about the difference between ionic and covalent. Let's see. Ionic compounds or ionic bonds, say. Ionic bonds occur between metals and nonmetals. So you'll have a metal bonded to a nonmetal. Transfer electron from the metal to the nonmetal. So ionic bonds involve the transfer of electrons from the metal to the non-metal. This happens because metals like to give up electrons to form cations. Non-metals likes to accept them to become anions.
Say that again. I just want to write it down.
Okay.
You don't mind? So.
Metals give up electrons to form cations. And non-metals like to accept the electrons to form anions. So think I want to say this. We'll learn in later chapters that ionic bonds are the strongest type of bonds. And if you have an ionic compound in a solid phase, it is composed of a lattice. A lattice is a regular 3D array of alternating cation and anion. So if I looked at it on the molecular level, this is what it would look like. This differs from covalent compounds because they have a specific arrangement of how they'll bond, whereas ionic compounds, it's literally just cation negative, or positive negative, positive negative, positive negative. Lattice. The little common ion table I gave y'all, that will come in handy when we start talking about forming ionic compounds, which we'll do in just a few minutes. But let me go ahead and give you the definition of covalent bonds. Sorry, I'll give you a minute.
Do we need to
This, you don't, but I mean, it's a good visual so you can see in your mind. Okay. difference in these two words is based on what type of bonds that are involved. So compounds are referring to ionic bonds. Molecules are referring to covalent bonds. I don't count off if you say I formed a molecule making with these ionic bonds. I just wanted you to know the difference. But I don't expect you to automatically know these words cannot be used interchangeably. Alright, so what is a covalent bond? A covalent bond, you're sharing electrons. The only elements that are good at sharing are your nonmetals and/or your nonmetal and a metalloid. So a covalent compound is either going to be between two nonmetals or between a nonmetal and a metalloid. Never a metal.
And the metalloids are
the black box that I have marked out on your periodic table.
I'm guessing the transition metals are ionic.
Yes. So covalent bonded atoms form a molecule. Let me show you how that differs from an ionic compound. So in an ionic compound, I'm simply alternating elements, positive, negative, positive, negative. A covalent molecule has a specific 3D geometry. That's what I'm trying to say. So example, this is water. This is how water bonds together in this exact arrangement. So I'm not just alternating positive and negative when I'm talking about covalent. Okay. All right, so let me mention the different types of chemical formulas. Then we'll talk about forming ionic bonds. I'll give y'all a second to get on that. What? Sorry. there are 3 types of chemical formulas. I've lost my train of thought because the CrossFit class that I wanted to go to is full. I meant to change it earlier and I forgot. Alright, 3 different types of chemical formulas. The first is an empirical formula. Empirical just means it is the simplest whole number ratio. I'll give you an example in just a sec. The next one is molecular formula. And then lastly is the structural formula. Structural formula would be like I showed you with water. For ionic compounds, you're always going to have the simplest formula. That's just how they work. Empirical and molecular formulas, they are only different for covalent compounds or molecules. An example
For the covalent?
Yes. Would be, let's see.
And the structural is always ionic? Well, not always, but.
The structural is always for covalent too, because the ionic don't form a specific structure.
That's right.
So really these only differ for covalent compounds. But let's see, I'm trying to think of a good example.
Is this the empirical?
Yes. Alright, so the difference between molecular and empirical. Empirical will always be the smallest whole number ratio. Smallest whole number ratio. Molecular shows the exact number.
You just explained that so much better in such a short amount of time than the integrated chemistry teaching. I mean, like the whole semester, everybody was like,
Yeah, but you already know your geometries too, because y'all do that lab. So again, these really are only going to be different for covalent compounds. Which are technically called molecules. Okay. Questions?
Are you saying that the empirical molecular formula is really different than the compounds?
For what now? Sorry, repeat.
Like when you
The-
say covalent compounds, molecules are.
This only applies to
The
them
covalent.
Okay.
because ionic compounds only have one formula and it's always the empirical formula. Okay, so let's talk. We'll do ionic compounds first. Can I erase this or y'all still write? Deja, you good?
How old are you?
What?
Well, you're up there moving around a lot.
No, my family members are bothering me. Whew, okay.
It's Monday,
It is
y'all.
Monday. It is very Monday.
And you would give us the.
It is.
It's a really great.
Yeah, I mean, and you would give us these polyatomic ions on Monday.
Because y'all have nothing else to do. I mean,
Like, yeah.
I don't even get to go to CrossFit, obviously,
I mean,
today.
add on 10 more then. I do that all the time. I like.
The
forget
problem
to read books
is-
and-
It's COVID. COVID is the problem.
Oh, I agree.
We can only
Everything.
have 9 people there at a time. And the 9 people have already,
Signed up. You have to be on it right now.
It's all scam.
I agree.
It's not as important for us.
like, I'm thinking about, like, texting one of these people and being like, I need you to, like, drop out of that class so I can go.
It
Or I
never
should
hurts
just
to
show
ask.
up, you know? Like,
Just
who
show me.
cares?
Say, I signed up, did not show up.
Right.
Like, yeah, I didn't. My name,
Yeah.
I was the second person to shut it down. I don't know what happened.
You
Yeah.
really should do that.
Because nowhere else are they doing Marla, are they like, like even in Greenville, Mississippi at that golf tournament, they know like there was no.
Oh, no.
It
I
was
went
like
to the
400
horse
people there.
races Saturday.
Yeah,
It was the first time they've been open to spectators since
Right.
March. There were signs everywhere like, please keep 6 feet. There was not a soul 6 feet apart.
no,
Exactly.
But only here, but Clinton is the only one that's still really enforcing it, because I went to get ink at the Walgreens, last night. And I went up to the register to check out over in the photo
Yeah.
section. And then there was a guy like printing out photos over here, and that lady was, the lady behind the counter was like, ma'am, you need to take 6 feet, stand 6 feet back. I'm like, well, do I have to throw the ink at you now?
Right.
You should.
Like I'm at the counter paying. Like, are you gonna catch it? You know, like, and do I have to come through that little hole in the little plastic glass you put up?
Yeah.
I'm like,
No, the best,
but it
was
was
at the
only-
post office, y'all. They had, when this all started, they had a clear shower curtain hung up. I was like, no, y'all do not do this. Ooh.
Oh my god.
Like,
Yeah, because I was sitting there thinking, am I gonna get this through that little hole? Because I'm just gonna have to chunk this out.
oh my god. About like the day.
The mascara shop take care of first.
At first.
Yes, that was important.
You got it.
Oh,
I think it's good face right here.
We probably is in a bad one.
If it's whatever made you ill, I guess it was one night last week, then you just walk away from that.
Walmart business went well. Because they closed the other entrance and then just come out with everybody closer together.
Yeah, and that, but you,
Just
What? You're mad at Walmart? I'm confused.
he's got a lot of problems going on over here. He is so polyatomic right now.
I think we all are. Okay. I'll tell y'all another story me get through ionic compounds.
Yeah.
All right, for writing formulas for ionic compounds. For an ionic compound, the sum of the charge of the cation must equal the sum of the charge of the anion. That's real nice. A lot of words.
Just means the anion and the cation have
What
to
if
equal.
they don't, they're not equal?
You have to make them equal.
You start stealing electrons,
This is balancing.
stealing them.
Okay, so let's say that, let's see what I want to form. I want to form an ionic compound between calcium and chlorine. In order to do that, I've got to make sure that their charges balance each other out so that I get a zero net charge.
Oh, we can start balancing equations.
No, not yet.
You do ionic balancing equations.
Oh, it's coming, it's coming. All right, well, what kind of ion does calcium form?
Calcium, let me get my
+2.
little shade.
And chlorine? -1. So in other words, in order for the sum of their charges to equal, I've got to have 2 chlorines for every 1 calcium.
Oh, I know what you do. I think.
Yes. Okay, well, some of these, thinking like that, it's going to take too much time.
Okay.
So there's a better way.
I'll do it.
You take, so this is 1, understood to be a 1 here. You take the number of each of these, you swap and drop. So calcium gets this 1, chlorine gets this 2. I drop them down because they are subscripts, so it'd be CaCl2. Swap and drop.
Oh, that is much better. Why didn't she teach us like that?
Everybody, I guess, is their own.
Yeah. So
Let's see.
it's the 1. This is 2. I like that swallow. And
I'm so hungry.
Right.
I'm gonna take out the-
Let's do another one. Let's do magnesium and oxygen. What ion does magnesium form?
+2.
Yes. And oxygen?
-2.
So if I took my 2 numbers, swapped and dropped, I would get Mg2O2. For ionic compounds, we always want the smallest whole number ratio. So could we simplify that?
Yes.
We could. So that's what we do. We simplify it to MgO.
Because they cancel each other.
So how do we name these compounds? Naming ionic compounds, we'll do main group metals first. So when I say main group metals, I'm referring to group 1, 2, and aluminum.
There may not be a lot of math on this test, but there's still a lot of information.
Yes, there is. Different things. Alright, naming ionic compounds with main group metals is the easiest naming system. Name of metal. There's two parts. You name the metal first, always, and you always write the metal first, because it's positive charge, it goes first. The second part of the name comes from the non-metal. So you take the root name of your non-metal and you add the IDE ending. So if I were to name this compound between calcium and chlorine, it would be calcium, plain calcium, chloride, IDE, instead of chlorine. I just changed that ending.
Oh, it's leaking here. I feel it.
All right, the other one would be just magnesium oxide, yes. So oxygen becomes oxide.
You are rewriting.
Yes, these two examples. I'll write the formulas by them. All right, let's take a quick 5-minute break. I need to get more water.